Okay, so welcome to what is this, part 4 of our Zoom call lessons. I know this week you guys got a message yesterday about grades and how school will look going forward, the last day of grading and all that stuff. The biggest thing there is that we're going to keep moving forward. However, your grade cannot go down. Okay, so currently your grade is going to be the 3 9 weeks averaged out, um, and that's it. Unless you do the work from previous month up to the next month. And what we're going to do is we're going to take some grades from there, and then those will be like grade recovery grades. Okay, so they're going to help you out on stuff you didn't do too hot on the first 3 9 weeks. So even before I got here. Okay, so if and they'll kind of go out evenly, and at me and Ms. Tillman and I's discretion. Okay, so it's kind of how we decide to grade where and where to place them. But it will be helpful for you to continue to work and move forward. Even if you're happy with like an 85, it's a good shot. You could potentially work hard, do everything, and make an A. All right, so it's not the end of the world. But also, I'll say that if you are more stressed about another class, make sure you're balancing what you need to do with how much time you have. Don't be doing school for 8 hours a day. Um, Even in like regular school, you're not actually working for 8 hours a day. So pace yourself. This isn't summer break yet, but also this doesn't need to be a 40-hour-a-week job for you. Okay, so you have a lot going on with all this craziness, and I understand that. I'm sure your parents do, guardians do as well. But we are still moving forward, so we're still going to have these twice a week with me and twice a week with Ms. Tillman for support. And we're still going to be doing lessons and still doing work and stuff. So keep doing the work as you have been, and if you haven't, pick it up. And it can only help you, right? It can't hurt you. So it's a good idea. It's a good idea to just give it a shot, and try to get as much out of it as you can for the rest of the year. If you have any questions about my class specifically, let me know. I can't really speak for other teachers, but that's kind of how we're moving forward. I think it's pretty common. But if you have any questions, let me know, and I will get started on all of this. So we are continuing the lesson on comparing geometric and arithmetic sequences. So the stuff we did pretty much right before we got out were geometric sequences, and the stuff forever ago, a while ago, was arithmetic sequences. Let me talk about the difference again. Arithmetic is when you're adding or subtracting the same number every time. 1, 3, 5, 7, 9, going up by 2, right? So it's 1, we're adding 2, we're adding 2, we're adding 2. And again, I'm using this analogy of these numbers are people in a line, okay? And the numbers are the names of the people, okay? So if I want to know the 15th person in line without counting out 15 people, I have a formula that'll actually allow me to get there without counting them down each time, okay? So it's really helpful that I have these formulas to do that. Arithmetic sequences, imagine that line of people. I kind of use like the lunch line, or elementary school, you have the line leader. The line leader, the first person in line is the first term. The second person in line is the second term. Okay, it's kind of how you can think of these numbers in a list, or in a series, in a sequence, is people on a line, and their position in line, in the number line, basically, is their term number. Okay, so if they are first in line, they are the first term. If they are second in line, they're the second term, and so on and so forth. So the 15th term is the 15th person in line. Now, I don't want to have to count all the way there, so that's when I use my formulas. Arithmetic is going up or down by the same amount every time. It's going to be consistent that way. A constant difference is what it's called. That could be addition or subtraction. But when you don't have a common difference, or common difference, but you have a common ratio, that's geometric sequences. That's what we did right before we got out. That's when you're multiplying by like 2 every time or 1/2 every time. You're multiplying by the same number to go from the first to the second, from the second to the third, to the third, to the fourth. That's called a common ratio. Okay, so I talked about how to get those common differences and ratios in the last video. So if you haven't checked that, if you haven't watched that one out, watch that one now, and then come back when this is posted, watch the rest of this. Okay, so if you're totally lost right now, go back, watch that, and then we'll watch all the other stuff. But I think we can pick up from here. This is kind of different though, because this one looks a little wonky. Okay, this one looks a little crazy. Don't be alarmed. It's not as bad as it might seem. So I'm going to jump right into it. Starting with number 13. Again, if you have questions, let me know. So these 6 problems, these 8 problems right here, 13 through 20, they want you to find the first 4 terms and then find the 10th term. Okay, so let's start with the first term. We got to find the first term. And so we have a couple ways to note the first term. We have either F1, that means the first term, or we can say A sub 1. Those both mean the first term. Okay, that little 1 where the N would go means the first term, because remember, N means term number. N per number. Okay, so to find the first term, what you do is you plug in 1 for N into the problem. So if we are looking at this formula right here, you have 2 times 1 plus 1 over 1 cubed. All I'm doing there is plugging in 1 for N. I haven't actually done any computations, I haven't solved anything out yet. All I'm doing is plugging in 1 for N. Okay, again, step by step here. Now, what I'm going to do is I'm going to simplify and see what I can do. So I think we can agree that 2 times 1 is 2. And I think 1 raised to the 3rd power is still 1. All right, 2 plus 1 over 1. Now, I'm not quite done. I can still simplify. Okay, so this kind of becomes 3 over 1, which is 3. Okay, so I found my first term. This is still A sub 1. Okay, so I found my first term, and I ended up getting 3. So that was my first term. Now, not quite done because I need the first 4. So I got to find the second, third, fourth. And the process actually stays the same. So let's figure out what the second term is with the same process. Good morning, Jeter. Okay, so again, step by step, list out everything, especially working at home. Okay, when we're in class, skipping steps, I can deal with that. But now that we're at home and you're kind of learning and teaching ourselves, don't skip steps. Okay, you really, really want to list out everything. So that's 2. Instead of 1 this time, I'm going to plug in 2. I'm going to add 1. I'm going to go over.
Doggone it, you supposed to be listening to this and watching this.
Come on, I've already done that part of the worksheet.
I'm sorry? Did I hear a question?
Actually, I got one.
All right, speak up.
All right, so whatever is with F in the parentheses, that's what's the substitution for N?
Yes, exactly. So In the formula up here, like this is the same thing as f of n. Okay, so whatever number we're using, we're substituting in for n right here. That term number we're looking for is the same exact number we're going to plug in for the rest of it.
All
So
right.
if you start with 2, use 2 for the rest of it. You start with 3, you got to use 3. Okay. All right. Good question. So 2 times 2 is going to be 4 plus 1 all divided by 2 raised to the third power. 2 times 2 times 2, 8. Okay, and then we can simplify that one more time. Okay, 4 plus 1 is 5 over 8 on the bottom. Okay, so 5. All right, I'm actually going to circle them in blue so we don't lose them here. This is the first term. This is the second term. We have the first two terms. I can't really see a pattern yet, going from 3 to 5 over 8. So we're going to keep on doing it the same way we've been doing it. So for the third term,
Tell him to fix something.
and this time, Michael, instead of plugging in 2, since we started with 3 for n, we're going to plug in 3. Okay. So we're working with 3 now, so we're gonna use 3 for this. So 3 plus 1 divided by 3 raised to the third power. I'm getting all this mess from the original formula, which is given to you in the problem. Okay, so that's what we're going to be using for all these problems, this process. But the formula is going to be a little different. Okay. So again, we want to simplify a little bit. Let's start with 2 times 3. My internet might go out. I don't think so. I hope not. It just told me my connection's unstable. We'll just roll the punches via there. So simplifying, we have 2 times 3, which is 6. And then 3 cubed, 3 raised to the third power, is 27. That simplifies to be 7 over 27. There's my third term. Okay. And then same process with the fourth one. Again, if I'm moving kind of fast, it's because I want to get through some problems in a reasonable amount of time, so I can post it to YouTube. And you can always go back and watch the videos later if you need to, okay? And email me any questions or remind whatever platform you want to use. So this time we're going to use 4.
Quit standing there. I'm busy. Go.
Okay. So 2 times 4 is 8. And 4 cubed, we believe, is 64. So 8 plus 1 simplifies to be 9.
You could have just went and asked him yourself.
Okay. So that's my first 4 terms. First term, second term, third term, fourth term, and you plug in corresponding number in there for n. Okay. Now for the 10th term, nothing changes. Okay, we're just using 10 this time. Two times 10 plus 1 over 10 raised 10 cubed. Okay. So I think 2 times 10 is 20 plus 1. Or let's do it piece by piece. So 20 plus 1 divided by 10 cubed. 10 times 10 times 10,000. That simplifies to be like 21 over 1,000. 20 plus 1 is 21. Okay, so I have my first, my second, third, fourth, and my 10th term. It seems like a lot of stuff's going on, but I don't think so. Okay, it's the same process. We're using 1, 2, 3, 4, and 10 as the numbers that we're substituting in, depending on which term exactly we're solving for at the moment. So again, the process is going to be repeated every time. It's not a lot of craziness outside of the craziness that the problem gives. Okay. Please do ask questions if you got me. Okay. And my computer's really quiet, Mike. So just like wave and yell at me, and I'll be able to hear you. Or put them in the chat box too. That's probably quicker. That'll get my attention if I don't hear you. Okay, so I'm going to skip down to number, let's do number 18. Well, let's do 18. 18 is good. Okay. So again, if you haven't finished copying this down, the video will be up in less than an hour. Okay. So you can pick up from wherever you left off. So let's go back and look at number 18. Marker drying up. All right, so this one's weird, but don't be alarmed. So we got 18, that's a sub n equals a n minus 1 times 2. Then it says the first term is at -1. Okay, again, we're looking for the first 4. What number was that? We just did number 13 on the 4th page, or 3rd page. Yeah, thanks, Mike. 13. So number 18, again, this is on page 3. Looks a little different, but it's not any crazier. Okay, it's not any crazier. And we just gotta approach it a little differently. Okay, so let's find the first term. Done. Cool. First term's done. This a sub 1 right here means the first term. Okay. So if you see that, this means first term. Again, I know that because that little 1 in the corner there. Okay. That's the same thing as saying like f of 1. This is the same thing. Both of those are the same thing. All right. Okay. So we have our first term. Now we got to find the second, third, fourth, and fifth. Well, and 10th, sorry. So let me walk you through how to find the second term. So if I want to find the second term, I need to plug in 2 wherever n is, okay? So this is a 2 minus 1. Keep that minus 1 down there. That'll be important. Times 2. Okay, so again, my second term, 2 minus 1 is 1. So that'll give us 1 times 2. But I know a sub 1 actually. I know my first term. It was given to me earlier. Okay, so I have to substitute in a negative 1 for this first term placeholder. Okay, so this a sub 1 is my placeholder for whenever I don't know what that term is. However, I do know what this term is, and that term was given to me in the problem, and that's negative 1. So that's negative 1 times 2. So a sub 2 is negative 2. Okay, I'm gonna let that marinate for a second. We'll walk through again what I did. I was given my first term. I knew I needed to find my second term next. To find that, all I did was rewrite the formula I was given, but plug in 2 for n because I'm looking for the second term. Again, n is the term number I'm looking for. So 2 minus 1 left me with 1 down here because that minus 1 is attached to the n. So 2 minus 1 left me with a 1 down here. Still got to multiply by 2. Now I see a sub 1. What in the world? Okay. I know my first term. I know a sub 1 because that was actually given to me in the problem. I couldn't have just pulled that out of thin air. I had to have known that to continue. If you notice, 17 through 20 give you that first term. Okay, so that's going to help you. I couldn't just start from there. Okay, I had to actually know the first term. Knowing the first term, I could substitute it in. That would be negative 1 times 2 still stays there. And then I actually solve it, and I get a sub 2 is negative 2. That's new, I think. Pretty sure. At least for me, with y'all. That's new. So it's okay if it's a little confusing. We're going to keep going. Notice that was just the second term. I still have to find third, fourth, and 10th. So for the third term, the process is exactly the same. Okay, I'm actually going to do that over here on the side. I'll do it in blue. So if I need to find, I'll draw a little arrow. So if I need to find a sub 3, that's a 3. I need to find a sub 3 minus 1 times 2. Right? So all I'll do is plug in 3 for n. And again, n is up there in the problem. Okay? So that leaves me with a3 is a 3 minus 1 is 2 times 2. I actually know this. Look at that. I know my second term. And that's negative 2. So this substitutes in for that. And I get a sub 3 equals negative 2 times 2. This is the placeholder. This a sub 2 is the placeholder for this number. Okay. It stays there until I find that number, and that's when I can plug in that number for that placeholder. And then, so a sub 3 is negative 4. 2 times negative 2. Okay, so let's see if we notice a pattern here. I actually ended up finding my first term. It looks like, let me back up 5 seconds there. The pattern here is taking this n minus 1, if a sub n is the term we're looking for, let me go back one space, or yeah, back one space in line, the previous term. Okay, let me repeat that. If a sub n, this thing, is the term number we're looking for, a sub n minus 1 is the previous term. It's like where I'm at minus 1. If I'm in third in line, minus 1 is going to be second in line. If I'm 15th, I'm looking for the 15th in line, I got to use the 14th number because it's the previous term. Okay, so this pattern here, number 18, is the previous term times 2. The previous term times 2. Let's check that because let's see if I'm not making that up. I want to find a sub 2. What I did was I multiplied a sub 1, which is the previous term, times 2. If I was looking for the third term, all I did was multiply the second term times 2. So let's kind of expand that. I'm looking for the fourth term. I think we can guess that it's going to be the third term times 2. The fourth term is going to, and so on and so forth. Okay, so let me double check that though, because this first step is important. But I just wanted to just make that connection to see if you could see if we can skip that there. So 4 minus 1 times 2. You also see that? Okay. I actually know this here. That goes there. Let me draw that arrow correctly. So A4 is but yeah, that's true. Okay, so what we figured out is that's true. Then for this one, number 18, and the rest of them, is the previous term times some stuff. Okay, definitely fit over here. So it is the previous term. In this case, it's times 2. I think with 17, it's plus 10. Okay, so what you're doing to that previous term can change every time, but the process is still similar process to the problem we just did, but we're dealing with the previous term. It's got to build on each other. You got to find the next term to find the next, to find the next, to find the next. Okay. Coming up on 30 minutes, so I'm shooting for 45 today. So I'll get through probably a couple more. I do want to talk about the last page. So let me get to the last page here. And again, this is due tomorrow night. No, sorry, Friday night at midnight. Okay, so you have today, tomorrow, and Friday to get us some questions. Come back tomorrow for the support session. Ask a bunch of questions. We'll work out some stuff. Email us. You have a lot of time. Okay, so all right. Again, I'm going to erase it all. You can go back to the video, pause it wherever you need. Okay, so I want to talk about the last page here. I want to talk about number 21. We'll start with 21. Okay, so this is 21. I think it's giving us negative 12, negative 9, negative 6. Okay. Again, we were dealing with that line of numbers. Now we'll talk about, this is the line leader. First in line, second in line, third, fourth, fifth in line. So in line means first term, second term, third term, fourth term, fifth term. Okay. And it goes in order like that. So here, what it wants to do is write the explicit rule, explicit formula for each sequence. The word explicit is not brand new. We talked about that with geometric and arithmetic sequences. And actually, at the top of the page there, I gave you the explicit formula for each. You just kind of have to fill in the blanks. Those blanks being the first term and the common difference or common ratio. I kind of have arrows pointing to all of those. So fill in the blanks with what you need to actually write the formula. Okay. But in order to do that, we got to figure out, first, is it arithmetic or geometric? Second, so let me write that on the board. To do that, first, is it arithmetic or geometric? Second, what is the first term? And then third, common ratio or difference. There's some more room here, go here, and then fourth is the formula. Okay, so first thing we got to do is we got to figure out if it's arithmetic or geometric. The big way to know is to figure out, does it have a common difference? If yes, arithmetic. Does it have a common ratio? If yes, geometric. So let's walk through that here. So let's check. And again, to do that, you take the second term, subtract the first term. Take the next term, subtract the previous term. So let's take the -9, which is the second term, minus the first term, which is -9 plus 12, which is 3. Now, go from -9, go to the next term. So then you take -6, subtract the previous term, which is -9. That gives me -6 plus 9 gives me 3. We're on the right track so far. Let's check it one more time. -3 subtract -6 is -3 plus 6, which is 3. Bingo. There is a common difference of 3, which means it's arithmetic. We have a common difference. If the common difference didn't work, we would have to then check for a common ratio, and then that would mean it's geometric, and then whatever we find. Okay, we'll get there. So I found my common difference. Now I gotta list my first term. So my first term, or if you want to write it like this, it's fine, is my first term in line, which is -12. My common difference in ratio, or common difference or ratio, in this case it was difference. So my difference is 3. Now I want to look at that formula where it says A sub n equals my first term -12 plus, I'm just going to leave that times my difference, which is n minus 1 stays as n minus 1 because we don't know what that is yet, right? That's the previous term. What n minus 1 is specifically, number-wise, the term depends on the number you're actually looking for. So that's how you just fill in the blanks in the formula that you find. Again, that's the common difference or ratio, and that's the first term. I'm going to do 22 as well, and then I'll take any questions from there.
Tell Mr. Charles to
Again, I know I'm moving sort of fast, just to fit it in a timely manner into the video. You can always go back. Okay. So all I need to change here for this problem is the list of numbers. Need to erase that. Okay. So if your paper looks something like that, then you're ready to start the next problem because it has like an outline, I guess you could say, to figure out what it is. So let's do number 22.
I don't think so.
Which is 2, 6, 18, 54. Is that it? 162. Okay. So first things first, we got to figure out if it's arithmetic or geometric. To do that, we're going to look at the numbers and figure out the difference. To save a little bit of time on my end, just to show you an example of the other kind of problem, let's check if it's arithmetic without me writing it all out. I'll just talk about it and show you that it's not. Look at the difference there. To go from 2 to 6 is 4, and from 6 to 18 is not 4. Okay, so it can't be arithmetic. It's not growing by the same number every time. It's not simply adding the same number or subtracting the same number every time. So this is going to be an example of a geometric sequence, but let me show you how I know. To find the common ratio, last time was a common difference, this time is a common ratio, so let's check. And again, I know it's not arithmetic because it doesn't have that common difference. That common difference is the number, like the change every time, right? So from 2 to 6, 6 to 18, that's not a common difference. Okay. So let's check common ratio. What you do is, instead of taking the second term minus the first term, take the second term divided by the first term. Take the next term divided by the previous term. So let's take the next term, which is 6, divide it by 2. That gives me 3. A ratio of 3, not a difference of 3. I'm not adding 3, I'm multiplying by 3. Let's keep checking that. So you have 18 divided by 6, which is 3. 54 divided by 18, which is 3. Okay, bingo. So I have common ratio of 3. 3 is my common ratio this time, so it's going to stand in for R instead of D. So I'm going to be using that right formula up top, the one that's for geometric sequences. Okay. So let's work down the line here. The first term is given to us. Just look at the problem. Look at the line leader there. That's 2. I already did the hard math for finding my common ratio. So my ratio is 3. And this formula looks a little different, but the idea is exactly the same. So where it says a sub 1, where that first term is pointing to in the formula there, plug in your first term, which is what we found there. Okay, so that formula is going to look like 2. And you can do the cross for multiplication, or like the X for multiplication. You can do the dot or the parentheses. I'm going to use the parentheses. Ratio, we found that, 3. Raise it in this one. Ta-da! That's the problem there. So with everything, again, we kind of, this is the hard math step. This is taking out the line leader, rewriting what we found, and then putting it all into the formula. Any questions? Can I answer anything? Is there anything? Don't know. Chat it, type it first, and if I can't hear you, if I can't understand it, I'll. But as you're thinking of some questions, 23 through 26 is exactly the same. What I would do maybe today, try them. Just try as many as you can, and if you just get stuck, fine, put it down, come back tomorrow. Send me a message saying, hey, I had trouble with this. What can I do? Again, let me make sure I clarify this at the end of the video. Class is still moving forward. We're still going to keep working. If you want your grade to go up, continue to work. You just doing your best and giving your best shot is going to help you a lot here. Okay, I'm about to stop the recording and just take a bunch of questions. Make sure there's nothing else I want to say. All right. All right, good question, Michael. I'll keep this one in here. So, to get the common difference / ratio, can you subtract or only divide? The subtraction and the division are 2 different things. Let me write that up here. So to answer your question, you do both. And you do both to find different ones. That way it's up there in the video, and so you can pause it if you ever forget. Common term, or the next term. Subtract let me explain that real quick. Again, yeah, Ms. Tillman, good point there. Difference means subtract. So difference means subtract. Ratio means divide. So this is like 2 minus f of 1. That'll give you the common difference. And this is f of 2 divided by f of 1. That'll give you the ratio. If I'm using the second and the first term there. Hopefully that helps answer your question. Good question. Any other questions or anything I can do for you? All right, well, I think I'm going to stop the recording there so it's not too long for YouTube, but I'll still be in the call.